Hello, this is Brock Lemires, and in this recitation number 5 video, we are going to look at comments and functions in C. Okay, so the goals of this activity are to understand the reason for and the use of comments, and we also want to look at how to use functions in order to modularize our code. Okay, and as we walk through this, we're going to also pick up a couple other of little bit of knowledge. We are going to copy and move a file in SSH because what we're going to do is we're going to take our recitation 4 code and add to it. And so as a result, we'll learn how to copy a file, and then we'll learn how to move it into our new directory for this recitation. And then what we want to do is we'll go through the algorithm of finding the maximum value within an array, and then what we'll do is we'll look at how to put that into a function. Okay, so let's take a look at what we're going to do. The first thing we want to do is we have our r4a.c file from recitation number 4. Okay, and this was where you have 2 resistors in a circuit and you're going to prompt the user for the voltage and R1, and then you're going to create an array for R2, and then we used for loops to walk through to populate the R2 array for a bunch of different values, and then we calculate the current and the voltage and the power across them. We want to use this file, okay? So what I want to do is I'm going to go take this file and I want to copy it to another file, and I want to name it R5A. And then what I want to do is I want to move it into a recitation 5 directory. Okay? Alright, so we haven't done a move yet, I don't believe, in SSH. So I'm going to bring up PuTTY and I log in, and if I look at where I'm at, I'm in my home directory, and I look at my directories. I have recitation 1, 2, 3, and 4. First thing I want to do is I want to make a directory called rec5 for today's activity. And then if I look at what's in there, it's there. Now let's go into our rec4 directory. So I'm going to go cd to rec4. And if I look at what's in here, I have a whole bunch of stuff. And what I'm interested in is this r4a.c. So I'm going to copy that first to a new file called r5a. And the way I do it is I do it with a instruction or command called copy cp, and I'm going to say r4a.c, and then the new file name is going to be called r5a.c. If I go ahead and hit return and then I look at what happened, I now have created this copy called r5a. I am now going to move it using a command called mv. And now if you think about where we're at, we are in this directory. We're in rec4. We need to move the file back one directory and then down into the rec5 folder. Okay, so the way that you do that is like this. I'm going to go move r5a.c, and then what I'm going to do is I'm going to move it to .. and that means go back one directory, so that'll take us back into the home directory, and then I'm going to go into rec5, and then I do /. And what that means is that I say go into that directory and just put it there using the same name. Okay, so if I go ahead and do that move, if I immediately look at what's in rec4, the file's gone. R5a is gone. So I'm going to go back, cd ... go back, and I look at my folders, and I'm going to go cd into rec5. I look at what's in here. Ta-da! There it is. Okay, so now let's start emacking this little fella, and let's pull up another little window here. And what I'm going to do is I'm going to go into rec5 in this window, and then I'm going to go emacs.c. Not even close. Emacs r5a.c. Alright, so I'm up and running. Okay, so I have my file. Everything's good to go. Life is good. Okay? Alright. So now let's think about what we're going to be doing first. The first thing we want to do is look at comments. Okay, a comment is text that you put into a program that is not recognized by the compiler. The compiler will ignore it, and it's used as a way to document your code. And this is extremely important as the size of your program grows, because as you develop and then you go on to a new program and then you come back to an old program, it's really hard to remember what you did. Okay, so it's a way to kind of remind yourself of what you did. And then when you work on large software projects, you're going to be working with multiple people, so you need a way to describe to other people what your code did. All right, so in C there's 2 types of comments. You can do a block comment or line comment. A block comment is where you have a start and a stop. And so the forward slash asterisk is the start. And basically everything will be commented after it until it sees an asterisk forward slash. Okay. And this allows you to have comments that span multiple lines. Okay. So if I look at my code in Emacs, I can come in here, and if I came up to the top and I said forward slash asterisk, everything that's a comment will turn red. Look at it, my entire program just turned red. And that's because it says I'm going to comment everything after this. If I came down to like here and I put the end comment, it would recognize that it only wanted to comment out these 2 lines. And so this is a good comment if you want to do, like, you want to write a paragraph or something like that describing what the program does. But that's a line, or that's a block comment. Okay, so I'll do this. This is a block comment, whatever. Okay, and I end it right there. Life is good. Okay, the next comment that we have are line comments, and line comments are basically, they start with they're a double forward slash, and everything after the slash slash is a comment until it hits the end of the line. So this allows you to do cool stuff like you can still have a paragraph up here where you have multiple lines. It's just that you have to comment out each line, but it also allows you to put comments after a statement. Okay, so if I come back into my code, I could come down here and I could say, slash slash, this includes the standard IO header library, something like that. Notice that it's only turning red after the line. Okay, so we have everything we need in order to do some good commenting. All right, so let's talk about the different types of comments. The first thing that you do is usually you have a file header comment, which is a description of what goes on within the file, and you can make these look kind of pretty and stuff like that. But typically the things you're going to include are going to be your name of who wrote the code, the file name, even though it seems redundant, this is a good thing to have depending on the environment that you're in, and the date of what you did, and then the description, okay, of what the code does. And sometimes companies will actually define like this very rigid way to define these header comments, so much so that if you open this up, somebody could read the comment in the file header and say, oh, I know exactly what this does without even looking at the code. So sometimes the comments can be so detailed that you don't even need to, it'll tell you what the inputs are, what the outputs are, what the algorithm is behind it. Okay. All right. So if I wanted to do that, I could come up here. And so basically you'll always want to have these from here on out. So I'm going to go like this, and I put this dash like this. It's nothing more than to just make it look good. Okay. So if I come in here, I'm going to go author, Brock J. Lemires, and then I'm going to, whatever. We'll maybe put the file name, and it'll be called r5a.c, and then let's go pop, pop, and then we'll go date, and I'll just make up some random date, so like 10/1-2018 or something like that. You should use the real date, makes sense. And then I do something like that just to do a separation, and it's only to make it look good. Okay, so there's no rhyme or reason behind that other than it's kind of a nice thing. So this program will calculate power. Okay, and then what I do, or what I would recommend, is make it look good, do this. Okay, so now it's really obvious that this is just a description of what's going on in here, and you're good to go. Okay, another type of comment that we use is section separators. Okay, so when you have this long program, you're going to have variable declarations, you're going to have loops, you're going to have statements that do certain things. It's good to kind of separate these out using comments. And I always put this line all the way across, but you don't have to. Some people just put the dash, just a little description of what's going on. And it really helps when you have color-coded text editors. So Emacs is really good because it shows it in red. So if I did something like this where I go, library definitions or something like that, it's obvious that that's a comment. Sometimes when you look at it with just black and white text, these little dashes afterwards can make it a little bit easier to read, but that would be like a section separator. And then I might come down here and say, okay, now I'm going to do variable declarations. Okay, and then you come down here, or not close, so something like global constants or something like that. Global constant declarations. Okay, and then you come down here, and this is super important because maybe you come down here and it's like, okay, now I want this section of code to prompt the user for a value of R1, and then I'm going to populate my loop, and it just separates it out so that you can quickly come in and actually see what's going on in your code. Okay, all right, and then the third type of comment, third grouping of comment is a statement comment, and you can put a statement comment behind the actual statement. So for example, it describes kind of the algorithm of what you're doing, and you can put as many of these as you want. And a lot of times you'll have like multiple lines of comment to describe like one statement, okay? And it gives you an insight into what you did. So for example, like let's take a for loop where I'm calculating power. You know, I have this loop will walk through each element in the R2 array and calculate the power. That describes why I have this loop and what you're walking through, and it's okay. And then I do an equation, P equals IV. Well, if you didn't know anything about electricity, you might be like, what in the world is this equation? Well, you could put a comment that says power is calculated as P is equal to IV. So everybody's like, okay, this is where you calculate the power. And then if there was an issue, you would know where to go. Some comments are kind of redundant and don't help. So if you put comments that just describe exactly what the algorithm's doing or the statement, it's kind of silly. So like for example, here a good comment would be power is calculated as P equals IV. Here's a bad one. I look at this statement and I have P2 multiplied by I is equal to I multiplied by V, and my comment is multiply the I array element by the V array element and store in the P2 array. That's stupid because you can look at this and you know that that's what it's doing. It doesn't tell you anything about it. It doesn't tell you why you're doing it or what you're doing. So from here on out, what I'd like you to do is I'd like you to have every code, or specifically this R5A.C. I want you to have a file header. So go ahead and enter this information about yourself. And then I want you to put multiple section comments in here, section separator comments that kind of just describe the main areas of your code of what you're doing. You know, like prompt user, populating the R2 array, printing, stuff like that. So you should have that. And then I'd also like you to have, for the critical things that you do, I want you to put some of these statement comments in here. So right here, I would say like add R step to last value of R2 array. And if you look at this statement, the reason that I would put a comment there is I have R2 array I is equal to R2 array I minus 1. And you're like, what in the world are you doing there? You know, you're adding to I minus 1. Why are you doing that? So for the critical things, you want to put this comment in there. Okay, so that is commenting. Now we can turn our attention to the next topic, which is functions in C. Okay, so we've been using this word function quite a bit when we talk about things like, you know, printf and fgets and stuff like that. And it turns out that we're already using functions when we write these programs. What we're using, though, is we're using predefined functions that are provided for us in these libraries that we include. So the standard IO library, the standard lib library. And so those libraries just contain a whole bunch of functions that are the most popular functions that people typically use in C. When we discuss functions in the terms of learning the language, what we're really talking about is writing our own functions, okay? So a function is, you can think of it as, it's just a group of statements, a group of code that perform a specific task, okay? And the function is actually separated from your main routine. Your main is a function actually, but it's separated from it so that you can kind of start breaking up your code a little bit. Functions can be called from your main program or your main routine, or they can be called from other functions or other routines. And we do this for a variety of reasons. So the number one reason is to avoid rewriting the same code over and over. So if you have some algorithm that you keep using over and over and you notice that you're writing it out and then later in your code you have to do it again, so you write it all out again and then you notice you're writing it again, you might as well take that code and put it into a function, and then what you can do is every time you need that algorithm you can then just call it. Another advantage of this is to design your code so that it has a modular structure. So it's this whole idea of taking a big problem, breaking it down into smaller subsystems until the point that you have a subsystem so small that it's very trivial to design. So you break this huge algorithm down into something that just has a subsystem that's like A plus B. And A plus B is very easy to, write, it's very easy to debug, it's very easy to maintain. It's also easy to break it down and then assign to other developers. So you might have a program that has 1,000 functions. Well, you can break it up over a dozen engineers and say each engineer you have to you have to develop these 50 functions, and then we'll integrate it all together. Okay, so this whole hierarchical or modular design to coding is really what happens once you start getting big. Okay, so the way that I feel that is the best way to learn how to do a function is I can show you all the generic syntax, but I think it's better just to start right out with an example. Okay, so let's do the following. Let's say that we have some expression, some calculation that we need to make. And let's do the calculation of P is equal to I squared R. So this is the power across a resistor, okay? If you know the resistance and you know the current. And it's just a very basic equation. But let's say, for example, that we didn't want to keep writing this out, okay? So that is what we're going to code up. We're going to code some function to accomplish this. When you think of a function, it's good to think of it as a system that has inputs and outputs. Okay, this is the most basic way to think about it. In this situation, the output is going to be power, and we'll call it P, and it's going to have an input I and an input R. Within the function itself, it will do the calculation and then produce the output. So it's got inputs and outputs. Now, when we start thinking about coding this, you got to always remember there are no such things as inputs and outputs or variables that don't have a data type. Okay, so everything is encoded with ones and zeros in a computer, and you have to tell your program what those ones and zeros means. So in this example, we would have the type double for all the inputs and also for the output, but it's very important to keep that in mind when we actually start coding this up. Okay, this is what the code would look like when we implement it. And what we'll do is let's just start breaking down the pieces of this little function and seeing how it comes together. All right, so the first thing that you're going to notice is you are going to have a name of your function. All functions need to have a unique name that is not a keyword. Okay, so you can't call it main, or you can't call it you can call it main, but you can't call it printf. Okay, so in this situation, I've named my function power. Okay, and it's going to represent this calculation with these inputs and these outputs. Okay. The inputs to the function are going to be listed after the name of the function within parentheses, okay? And the way that you do this is you comma delimit the input variables, but you also have to put the type. So this is where you're going to have double, and then you would have a variable called I, or an input I, comma, and then you'd say double, and then R. By doing that, you give the order that the inputs come in, and that becomes important when the calling function passes these in. And you also give the type. Now these are actually declared as you do this. They're declared as local variables. So we are going to actually be able to use the variable I and the variable R within our program, and the calling function doesn't need to use I and R. These are what we're going to call the inputs once these values are passed into our function. So that's how the inputs are handled. Then the output it's actually listed, the type of the output is listed before the name of the function. Okay, and in this situation, it's going to be a double. So we actually just put the double right here, and then you're like, well, how do I know what is going to be returned? Well, the way that you do it is you are going to actually define an internal variable, and in this situation I created a double that I named P, and that alone doesn't actually do it all. What happens is that you are going to do some sort of coding, and in this situation, see how I did I times R, that did the calculation, we assigned it to P, but then we use this keyword return. Okay, and you've seen this before. We've been putting it in all of our main programs, but this return is a keyword that says this P right here, this variable named P, whatever the value is when you hit return, it is going to be returned of type double to whoever called us. Okay, so that's how you actually pass the result to the outside world. Okay, now where do you put this function? I mean, this code, where does it exist? For what we're going to do now in this class, our code is small enough we don't need to start breaking these up into other files, so you can actually put it in the same file as your main program. So for this function, for this assignment, this is r5a.c, we are going to put this code above the main function or the main program. Okay, and its main function is accurate. And the reason that I do that is because some compilers need to be able to see this. They read in the program line by line, and they need to know that something called power exists, because if you called power in main, it might say, hey, I don't even know what power is. So if you put the function before main, you're always safe. Now, as compilers have advanced, you can sometimes put them below the main function to make it a little bit more readable. I mean, it makes more sense. You usually start with main, and then you put the function below it. But I'm going to tell you, why fight it? I guarantee that it's always going to work if you put the functions above main. So let's just do that from now on out. Okay. All right. So now that's where you put it. It's actually in the same file. And then the question becomes, how do you call it? Well, once the compiler knows that it's there, within the calling function, all you're going to do is treat it just like a function. So in this situation, I'm going to have this variable that's in my main program. In this situation, it's called P2 array. And I'm going to calculate the power by passing in a current and passing in a resistance. Notice that the order of these is critical. Okay, the current is going to, whatever you list first, will be assigned to this input local variable I. So in this situation, I had to make sure I was passing it a current. Okay, the second variable listed or input listed is going to be assigned to whatever the second input is listed here. Now, you need to make sure that when you pass in the current and the resistance, they are of type double here, because they are expected to be of type double here. If they're not, you're going to get an error. Okay, and then what happens is when you call this function, it's going to return something. It's going to return a number that is of type double, and that double will be assigned into whatever variable you have right here. Okay. All right. So that's how we're going to do it. So let's do it. Okay. So let's go back to our program, and I'm sitting right here, and what I'm going to do is I'm going to come down after my libraries, after my global constants, but before my main function. Okay. And I'm going to do a nice comment here and make a separator, because I want to know, I want the world to know that right here is my function. Okay, so I come along over here, and now this is going to be my area, and I'm going to come right here and I'm going to go function power. Okay, and that just tells the name of it. Okay, so here I go. I'm going to type double. I'm going to give it the name power, and then I'm going to pass in a double that I'm going to call I once it's in this routine or this function, and then I also have another input called R, which is a type double. And then I'm going to open up my curly brackets. Okay, close my curly brackets. Within this, I'm going to declare a variable called P that's of type double. And this double that's called P, it's only going to be seen within my program, my function. Main can't see within here, okay? So this is a subsystem to main, so it can't get in here and mess with me, okay? It can use the word P, but it's a different variable than what's inside of my little function. All right, so then let's calculate it. P gets equal to I times R, boom. And now I'm done. So I go ahead and return P, and that's it. Okay, so I'm going to go Control X, Control Save. And at this point, I've made the function. I haven't run it yet. So let's go ahead and get a compile in here just to make sure that I didn't screw anything up. So I'm going to do a make R5A. Good. Now let's think about what we're going to do. We can use this function to calculate the power through a resistor. So I'm going to now walk down into my main program. Here's my main. I declared all my arrays for R2, I array, V out array, P2. I've created my step variable to when I populate my my resistor 2 array. I've got characters and doubles for V1 so that I can get it from the user and convert it to a double. I can get resistor 1 from the user and convert it to a double. And I have I, which is an integer, and I'm going to use that as my variable in my for loop. I walk down more. I prompt the user for V1. I convert it and store it in V1. I prompt the user for R1. I get it and I convert it to a double for R1. And then I have a loop that's going to populate the R2 array, and that's good to go. And now we're going to calculate and print loop. So within this loop, I'm looping through my R2 array, and I calculate the current. Okay, and then I calculate the output voltage. Now I'm ready to calculate the P2 array. Okay, so before I was calculating it by multiplying current times voltage. This time I don't want to do that. What I want to do is I'm going to use my new function called power. And in here, I need to give it the current first. So in this situation, I'm going to use I array I, index I, and that is going to grab the element of the I array at index I. And then I'm going to go ahead and pass it in the R2 array also at index I. And that's it. I'm done. I've just now used my function. So let's Control S, Control X, Control S. Let's come back over here. We'll make it up and let's run it. Okay, so let's run R5A. Boom. V. Let's give it a 9-volt battery. And let's give it a 44 ohmer. Check it out. Our R2 array is populated as it was. We have a current array which is populated, V out array which is populated, and we have the P2 array which is populated. And once again, we notice that as the resistance goes up, the power goes up, and then the power starts going down. And the maximum power occurs right around where R2 is equal to R1. Okay, so we kind of observed that last time. Okay, so we just did it. Now, I'm going to be honest with you, that's a pretty silly function because it didn't do anything other than just multiply some numbers together. But we did it so that we could learn the process. Most of the times functions have a little bit more complexity to that. Before we look at a really powerful function, let's just look at all the types of functions that you could have in C, because you could have four flavors based upon how many inputs you pass in. You could pass in some or none. And you could have a return value, or you could also have a return none. So let's think about this. The first one is functions with inputs and a return value. That's what we just did. We passed it the current and the resistance. We returned the power as a double. Okay, so we just did that first one. Look at this one though. Functions with inputs and no return value. You can absolutely create a function that doesn't return anything, but what you do is in the location where you would have given the type of the return value, you use the keyword void. And that tells the compiler, nothing's coming back from this. Okay, we don't need to prepare for anything to come back. Nothing's coming because it was void. An example of this is you pass in some number and this function just prints the number. Notice that we passed it something, but nothing was returned. All right, that's fine. Now check this one out. Without inputs and a return value. Here is finally where we can understand what int main is. Now, every time we've written our main program, we always do int main, and we don't give it any arguments. Okay, that's why we have parentheses there. Those parentheses would have been if you would have passed arguments in. We never even knew that until now, but we know now that that means main is a function that is not going to have any inputs. The question then becomes, what in the world, why are we returning an integer? Because we have an int as the return, and then down here we return 0. So when I execute this program, somebody who called it, I'm passing them a 0 when I'm done. Well, it turns out that this was, when they first created C, these main programs are typically called by a higher level program, namely the operating system. And what they decided was they came up with a coding scheme of when the program executes and ends gracefully, if you return a 0 to the operating system, and then the operating system says, oh, wonderful, I ran that program and nothing went wrong. And then there's this table of return integers that say, well, something went wrong, but don't worry about it. Something's catastrophic here. We need to do something major about this. But that's where this whole int main came from, is we actually return a code 0 to the calling function, in this situation is the operating system, and that tells the operating system that everything is just fine. Okay. The last one would be functions with no inputs and no return value. And this is kind of, it's kind of silly. It's like void echo name would be an example where you grab the name of the user, and then you print it back to them. It's just like a warm fuzzy to say that you're there. Now, as you go through, this is the extent of the functions we're ever going to use in this class. Okay, there's more to this, but I'll tell you that there are functions that don't have inputs and don't have return values that will manipulate global variables. So maybe you had some piece of memory that everybody was accessing, and you could call a function that would go over and modify it. It's not necessarily returning anything, but it is doing something important. But anyway, those are the four types of flavors of functions that we have in C. So now why don't we look at doing something a little bit more sophisticated. Okay, so the function that we looked at before, which was calculating the power through a resistor, was really simple, and you probably wouldn't even put that in a function. It's just good practice to learn how to do functions. But why don't we create a function that will walk through our array for power and find the maximum value? Okay, so that's something that would be of interest to us, because you remember that we've actually created these four arrays. Okay, so we created R2 array and we populated it with resistor values, and these resistor values represented a sweep of values on R2 within this voltage divider. And then associated with that, we also created an I array, which held the current, a V out array, which was the V out of this, and then we had the power. And all of the R2 I and the V out, those ones were kind of linear. It's like R2 just went up, I went down, V out went up, but power actually went up and then it went down. And so there was kind of like this there was this thing that happened where there was some optimal value of the R2 array, or of the R2 with respect to R1, that provided the maximum power. Okay, so it would be interesting to be able to walk through the P2 array and actually find out what that value was. Now, to begin with, we're going to put this in a function at some point, but we want to learn an algorithm to actually walk through one of these arrays and then find the maximum value, and then we'll package it up and put it inside of a function. Okay, so the first thing that we want to do in order to do this is we're going to create a variable that will hold the maximum value. Okay, and let's just call it A max, and that stands for array max, and it's a double because it's going to hold one of these values. And once we're done with our little algorithm, it'll hold a value that represents the maximum value within the P2 array. Okay, and what we're going to do is we're going to use a for loop to walk through the P2 array. Now the P2 array is already done. It's already been populated. It's already been calculated. We're just searching through it one by one in order to find the maximum value. So we'll just do a little for loop, and we'll walk through all the indices within this array, and we'll look at all of the values. Then what we can do is we can actually make a decision based upon the current value we're looking at and figure out if it's the highest one. So what we do is we start by initializing a max to a value, okay? And it doesn't really even matter what the value is, but it does matter that it's one of the values within the array. You don't want to just guess and say, well, we'll make it -1,000,000, because you never know what's going to be in the array. It could be -2,000,000, and then that would be less. So we always want to start it at kind of a value that exists within the set of values within the array, but it doesn't matter which one, because what we're ultimately going to do is we're going to compare this current value that's being stored in Amax to the value that we're looking at in our for loop, and then we're going to update it accordingly. Okay, so what I always do is I come along and let's just set it to the first value in the P2 array. So if you notice, that's what this does right here. So when I declared A max as a new variable, I just went ahead and initialized it to P2 array 0. And that just stuffed in, the first value in the array. Again, it doesn't matter which value you start with, because ultimately we're going to go through every value in the array and figure out which one's the max. You just need one that's in there, inside of the array. So I went ahead and just said P2 array 0. You could have done P2 array 10, whatever. Okay? So the algorithm here is as follows. You're going to go through every single one of these, and when you're looking at one, if the current value that you're looking at, which is in this if statement, is P2 array I, if it's greater than whatever's in A max, why don't you go ahead and update A max with that current value? If it is not greater, then that means A max is holding a value that is at this point the highest we've found. Don't do anything. Okay, so to don't do anything in an if statement, all you do is you just provide the statement that you're going to check, and then you only do an assignment when this is true. Otherwise, you don't do anything. Okay, let's look at how this might actually act. Okay, so we initialized our initial value A max to 0.316, and that was the first value in there. And then we went to index 1 in our for loop, and we noticed that index 1 had a value that was 1.118. That is indeed greater than A max, so what we did is we updated A max with 1.118. Okay, then we go to the next value, and it's like, oh, look at index 2 is actually 1.325. That's also higher than our past value of A max, which is 1.118. Let's go ahead and update that. We go to index 3. Look at this one. This one's also higher. 1.346 is higher than whatever the value is in A max. Let's go ahead and update that again. Then we go to index 4. Oh, wait a minute. This now, the value 1.303, that is not greater than 1.346, so I will not update it. So notice that A max now contains a value which is higher than the value at index 4. And if we do this all the way through the entire array, once we're done, A max will hold the value of the highest value in the array. And it's like, we're done. We found the maximum value. So it's like, that's the algorithm that we're going to use. It's a very sequential, one by one. You just check it, and we will ultimately find the value. Okay, but is the value what we're ultimately after? And the answer is, well, yes, it is. But we could find something that it would be even better than the value. What if we found the index of where the maximum value is? So in this little example that I'm doing, we found out that this number 1.346 was the highest so far in the array. Let's just say it was the highest in the array, but it was at index 3. You know what's so cool about this is that the way that we created our 4 arrays, they're all associated with each other. Okay, so index 0 is the R2 value corresponding to the current, corresponding to the V out, corresponding to the power. They're all associated with each other. So when I know the index, I could say if I had index 3, I would also not only know the power, I'd know what value of resistor that corresponded to, what the current was at that time, and what the V out was at that time. So this is really where the power of using these associated arrays come in, because you find one index and you find all this information. Okay, so what if we said, you know, I want to find ultimately the index of where that maximum power is. How would we do it? Okay, so let's go back to our original code here. So far we've got our for loop, which goes through and updates our variable A max. We can't get rid of A max, okay, because A max is what we are looking at the values within the array. Okay, so we have to still do that compare. However, we should create a new variable that will hold the index of where that maximum value is. So we'll go ahead and create some, let's call it imax for the index maximum, and it's of type int, and it needs to be initialized to some value, and we'll just initialize it to 0. And then what do we do within our for loop? Well, all you do is anytime you make an assignment to A max with the actual value within the array, go ahead and update imax. And in this way, when you're done with traversing this array, you not only have found the maximum value, you found the index. And in reality, the index is really all we care about, because once we have that in our main program, we can access all 4 of our arrays. Okay, so that's going to be the algorithm that we do, and we've written a little bit of code for it, and this code would work if you put it in your main program. However, we are working on functions. Okay, so what do we do to make this little algorithm a function? Okay, so that we start off by saying, okay, so here's what we got, and we're going to think about a function. First thing you always think about is, what are the inputs and the outputs to this thing? Okay, we are going to be looking at this array, P2 array, okay, and it is an array of doubles. We also had to pass in, or we also need to know how many points are in the array, because that sets, you know, how many times we're going to go through the array in our for loop. And then the output is now, it's just going to be the integer. Okay, it's going to be imax. Okay, so that's great. But what's interesting about this is that in this application, we are looking at power, but we don't have to. You know, this algorithm will work for any algorithm or for any array where we're just trying to find the maximum value. So whenever you build a function, you try to make it as generic as possible, because maybe we wanted to find the maximum resistor value in its array or the maximum current in its array. We want to make this very generic. So this is where we start thinking about the names of the inputs and the outputs, and maybe we don't call it P2 array. Maybe what we do is we call it something more generic by changing the input names and maybe modifying some of the internal variables that we use. So why don't we start by doing this? Instead of calling it P2 array, now remember, this is the code we're going to put in our function. Why don't we call it X array? X is just a very agnostic variable name. And what that would mean is that we would have to change X array within our code. So it's no longer P2 array. P2 array was something custom for our program that's going to be calling it. We're going to make this agnostic function that works for any array. So we'll just call this X array. That's going to be what we operate in within the function. So this is code that's going to go within the function. That means we had to change it in our initialization of AMAX. Array max is still pretty generic, so we'll leave that. X array, we compare that in our compare, and then we update AMAX with X array. Now we've changed that variable name to be more generic for within this function. You know what else we need to do? Endpoints was a pound define. We would like our function to be passed a value that is not global. Okay, that's not the same as the global, so that it's not confused. Why don't we just change that to n? Okay, and that's a very local agnostic thing to do. So we change the input to be n, and the only place that's really used is in the for condition checking. Okay, so now we're sitting there, and we've got some variables here that are pretty dang generic. And now we start thinking about, okay, how do we button this up into a function? Okay, so this is the code snip that we need to put into a function. So let's go ahead and think about what we need to do. The first thing we're going to do is think about what's returned. So IMAX is the actual return. That's what we're going to return to whoever calls us. So to do that, we are going to first put the type of what is returned, and in this situation it's an int. So we put that up here, and then what we need to do is we use the keyword return to, after we're all done calculating all the stuffs we're going to do, we'll go ahead and say return IMAX. So that is going to handle this whole situation where we return the integer. Okay, all right, so we got that. That's kind of like the output. Now we need a name. So we need to name the function. We could call it find power location or find maximum power location. But again, that's pretty specific to this program we're writing, right? We're trying to make this function very generic so it can operate on any one-dimensional array. Why don't we call it max location? And the location really tells you, it's like you're not returning the maximum value, you're returning the location within the array where the maximum value is. So that's the next thing that happens, is we put the max location name in there. And now let's look at the inputs. We are going to define these two inputs that come in, and we're going to have X array and n. And we need to put the type there. So the first type is a double. And X array, though, is an array. And the way that you tell C that it's going to be an array is you put the square brackets there. Okay? And that tells it that X array just isn't a single double, or a individual double variable. It is actually an array. Okay? And then int, of course, is it's an integer, which is the size that comes in, and that's called an n. Okay, so now we have the inputs coming in here. What else do we need to do? Well, we need to wrap the whole thing in curly brackets. Now that encompasses our entire code, and I feel pretty good, and so now I need to kind of look back through it and say, is there anything we missed? Well, you know what? When you do functions, you need to think about everything within this function is a local variable. Okay, so if you want something in here, you need to pass it in through the inputs. If you're going to use a variable within here, it needs to be declared within here, even if it's the same name as something that's in your main program. And the one that we missed, though, was in the main program we were using I as our for loop variable. And we had defined I. We always define I in our main program whenever we use loops, for loops specifically. But when we get in our local variable, it doesn't know what I is in the main program. So we need, if we're going to use I, we need to declare I. So I have to go in here and create int I. And it is the same name as the one used in main, but that's okay. It's a separate variable, and it's only used within this function. So this right here represents our really nice function that will walk through an array that is n long, and it will return the index of where the location is of the maximum value. The last step we need to do, though, is we need to call it. So how in the world are we going to call this? We go into our main program. All we do is we say max location, we pass in the P2 array, and we actually don't even need this square bracket here. You pass in the P2 array, and you pass in the size, which is n points, and then you assign it to some variable. So we have to have a variable somewhere, like P2 max, and we could call it P2 max, for example, but we have to have a variable that is returned to it. Okay, so this feels pretty good. Why don't we go ahead and do it? Okay, so I come back to my code, and I'm sitting here, and the last time I was messing around with my code, I had populated my array, I'd calculated everything, and I'd actually created a function called power, which calculates the power of a resistor, and it was just a playing around thing. So let's go up and let's code up this beautiful function. Okay, so I'm going to put this right below my power, and let's go ahead and put a comment. Let's put a comment thing in here so we can actually see, real quickly what's going on. So we'll go ahead and do bop bop, and we'll do this line over here, and it turns it red, which is nice. And then I'm going to do, this is going to be function to return the location of max value in an array, and here we go. I am going to type int max location, and remember, this is int is what we're returning, max location is the name. I'm going to go double, and I'm going to define x array as an array that will be a local variable within my function. I'm going to go ahead and say int n, and then I'm going to open up a curly, now come down here, close my curly, and I am now ready to code up this awesome function. First thing I'm going to do is create my double local variable called amax, and this is going to hold the maximum value during my compares of what's in the array. I need to initialize it to something, so for no other reason, I'm just going to make sure that it has a starting value that's at least within the array I'm looking at. So let's just assign it to the index 0, okay, whatever is at index 0. Again, it doesn't matter on that one. You know what else, though? I need a imax, which is going to be the location or the index of where the maximum value is. And then I also need a local I. Okay, so I'm going to use I in my for loop, so I need to have that. Now let's walk through the array. So I'm going to say for I is equal to 0. I'm going to start at index 0. And I'm going to say I'm going to loop as long as I is less than n. So that will allow me to step through from 0 to n minus 1. Walk through every value in the array. And each time I go through the loop, I'm going to increment my index variable by 1. Okay, all right, that sounds pretty good. And I'll go ahead and close that for loop up so I don't forget. Now, at each location, I'm going to look and say if x array at the one I'm looking at is greater than the current value I'm holding in amax, I would like to do the following. If it's bigger, then I need to update amax with that value. So I'll go ahead and do this statement right here. And then guess what else I'm going to do? While I've found a value that's higher, I'm going to go ahead and also record the location that was at. And I record that index by saying imax is equal to I. Alright, so this calculates it, and when this loop is done, amax will hold the maximum value in the x array, imax will hold the location. I don't even return amax. What I return is imax. That then will return this to the calling function, and I'm good to go. So I'm going to go ahead and save that. I have not called this, but I would like to get a compile in here to make sure that I didn't screw this up. So I'm going to go ahead and do a make on this. So make R5A. No. Oops, that ain't it. Make R5A. All right, we have an error. Unexpected. Okay, error n. We got some stuff in here. Oh, there's a semi. I didn't need this semicolon in here. Alrighty, let's make it again. Okay, no big deal. unexpected declaration or statement. What is this about? So we're at line, okay, max location. Oh, I didn't close my if. Gotta close your if. Okay, all right, then that's good. Good practice. Okay, make it. Beautiful. All right, so I got myself a function that at least compiles. I don't know if it's going to work yet. I'm going to come down and I need to go ahead and I need to call this thing. But remember, I need a place to put it. So I'm going to create a new variable that's called, what do you want to call it? Let's call it imax. Okay, and you go, imax, isn't that the same one that you created inside of the variable, inside of the function? It's like, it is true, but it's okay. You can have the same variable names in your main program and also in your function, because they're separate from each other. And if you want to make it different, I don't even know what you call it, imax. I want to call it a capital imax to make it a little bit different. All right, so we got capital imax, and we all feel good. All right, so I go down in my program and I calculated and I printed, and this, I'm at the end of my program right here. But what I want to do is I want to come down here and I'm going to now call my program. Not my program, my function. Okay, so all I do is this. I'm going to say I max equals max location, and then I'm going to pass it in the array I want to search. I am searching P2 array, and the size of it is n points, and that's all I do. I need to know if this worked, so let's go ahead and let's do some printf statements. So printf, and the first thing is I'm going to do this. I max equals, and I'm going to print the decimal value of it, and then I will print it. There's nothing else to say. imax. Okay, so I have this thing, and let's see if this program actually worked. Okay, so I come back over here, I make, and let's run this puppy. So I'm going to do run puppy, and it says, what's the value for V1? I'm going to give it 9 volts, and let's do 50 ohmer. Ooh, look at this. Okay, something happened. Imax is equal to 9. So it is returning something. At least it's at least it's getting through the program, and it gave me a number. I don't know if that's right, but we can kind of figure it out if it's right. First of all, R2 array goes from 1 to 100, as we would suspect. It's telling me that index 9 right here corresponds to the maximum power. So let me go over here, and let's see if this is the maximum power. It starts at, so this is saying index 9, it's like 0.03, 0.15. It's getting bigger, 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 bigger. Look at this, it did it. 0.4048, this one is 0.4046, and it goes down. It has now found the maximum index. It found it. This is awesome. You want to know why? Because once I have it, I can do the following. Watch this. I'm going to print out printf. Let's print out the maximum power was, and watch this. I'm going to just put a float, okay, and then the maximum power, I can find it within my P2 array by putting the location imax in the index within the square brackets. So check this out. The maximum power was, and I looked at my P2 array and I put imax. So let's Control X, Control Save. We'll go ahead and make it. We'll run it. And let's do 9 volts, 50 ohmers. And now I have the maximum power is 0.404. Oh, you know what's even more amazing? I can do this for the resistance. So let's go, oh my, let's go like this. Let's go, look at this. Let's go, the maximum power was the corresponding R2 was, and then instead of printing the power, I'll do the R2 array, and then I'll say the corresponding I was, and I'll put I array, and then I'll put the corresponding V out was, and I'll put the V out array, and look at what I'm doing. I'm using my index for all 4 arrays. This is unbelievable. So I control X, control save. Let's get a make. Let's get a run. Let's give it a 9 volt as an input. Let's do a 50 again because we kind of know what's going on. Boom. Look at this. We have the maximum index was 9. The maximum power was 0.404813. Got that. That correspond to this guy right here, which was 47 ohms, 91 milliamps, and 4.4 volts. You have done it. This is unbelievable. We have come a long way here. Okay, so you are done with this video. Okay, and look at this. Look at how happy I am. I mean, it's like teeth ear to ear here. I mean, this is unbelievable. And you're probably wondering what to do next, but it's probably good to just take a minute and look at how far you've come. I mean, we started by putting comments in your code, and then we went all the way to creating functions. We learned an algorithm to find the maximum value in an array. That involved looping through an array. It involved doing if-else statements, just an if, and it involved understanding how to index an array. And for that, I almost wonder if a really creepy smile is enough. You know what? It's not. You know what you're getting? Boom, you're getting a double thumbs up. Count them. 1, 2. That's for you guys, okay? That's just for you. Those don't come out very much, but I think you earned it. I really do, okay? So here's what you're going to do. You're going to go take the Rec 5 quiz, then you're going to go to your recitation, work on your program, and demo it to the recitation instructor. Remember, the program is going to be a little bit beyond what we covered in here, but not by much. And then you're going to upload your code, and you will be done with Recitation 5. Good job.